Let's evaluate some limits analytically. The first three are on the board, and they're going to involve basically some algebraic manipulation. You have seen this before, particularly with the first one. So let's jump in. If I wanted to evaluate this limit by just directly plugging in a 2, substituting a 2, yeah, good luck with that. You're going to actually end up with 0 in the denominator. Can't do that. And you would also have 0 in the numerator, which complicates your life. Now, eventually you're going to learn a strategy that was discovered by a man by the name of L'Hopital, and it's going to be called L'Hopital's rule, and that'll help us deal with situations like that. But in the meantime, let's go with what we do know. So this first one's not going to look too different. You have factored before, so let's just factor and just beat this up algebraically. Now, since we are not yet plugging in a 2, we have to continue to write limit as x approaches 2. So the limit as x approaches 2, I didn't write that very clearly, but we'll be okay. The denominator factors into x plus 2, x minus 2. The numerator factors into x minus 14 and x minus 2. And then very conveniently, x minus 2 cancels out. Lucky us. It always happens in real life that way too. And so we are left with the limit as x approaches 2 of x minus 14 over x plus 2. Now, as we look at that, we say, well, can I plug a 2 in now? Yes, I can. If you wanted to write one more step, you could. You don't have to write what I'm about to write. Don't feel like you have to do this, but I'm just rewriting it. Oops, 14. And just taking out the things that canceled out, divide it out. And so we're going to plug a 2 in now. So we're going to basically just have 2 minus 14. And once I plug in the 2, I don't have to write lim anymore because we are actually evaluating it. So 2 minus 14 and then 2 plus 2. So I'm going to end up with negative 12 over 4. Negative 12 over 4. Way too many steps there. Negative 3. You probably could jump straight from here to here. Okay? Now, as we get to the second problem, you're going to say, I can't factor that. You actually can factor that, and there's also a couple little tricks to it as well that are going to come in handy later. So let's first of all talk about the fact that I can't figure out what marker to write with. I'll stick with blue. As I look at this, I think, well, if I plug the 25 in, so 5 minus the square root of 25, that's 0. 25 minus 25, 0. I'd have 0 over 0. We're in the L'Hopital situation. You haven't learned it yet. Let's go old school. Let's just factor. So you're thinking, why are we going to learn about L'Hopital when I can just factor it? Because actually it's going to be shorter, but we do need to practice these skills now. And also, not everything factors, so L'Hopital is going to come in handy when we learn it. In the meantime, let's keep going. So the limit as x approaches 25. And then you're saying, well, factor, how do you factor? There's nobody squared, there's none of that. Okay, well, let's address things that don't look like they need to be addressed, but they do need to be addressed, and it's that numerator. And it's the fact that that numerator is, in my opinion, backwards. I like to have the x first. So if I was going to write the x first, I would put negative square root of x plus 5. And that's not wrong. That would be correct. It's just rearranging it. But another personal opinion of mine, I don't like to start with a negative. So what I'm going to do instead is factor a negative 1 out. So it's still going to start with the negative, but I'll have a negative 1, and then I'll have square root of x minus 5. Personal opinion, I think it just looks neater that way. Why did we do that? Because in a minute we're going to need to have had that done so we can cancel out some factors. The denominator doesn't look like it cancels or factors, but it does. It is actually the difference of two perfect squares. Perfect squares. Well, obviously 25 is 5 times 5, but x is the square root of x times the square root of x. So we can factor that into the square root of x plus 5 and the square root of x minus 5, and then automatically you see where this is going. And again, we haven't evaluated yet, so we're not going to leave off limit as x approaches 25, not until we plug that in. So let's cancel. We're going to cancel this with this, and I have the limit as x approaches 25 of negative 1 in the numerator and square root of x plus 5 in the denominator. At this point, it is totally okay to plug in a 25 and for your x. So we will have negative 1 over square root of 25, so 5 plus 5, which is 10. There we go. Okay, third problem actually does factor. It doesn't look like it does, but it does. Again, this one didn't look like it factored, but it does. And this one doesn't look like it factors, but it does. And so we're going to not factor it. We're not? Okay, I might in a minute, but I don't feel like it right now. I want to show you a different strategy, and it is, well, synthetic division. We could do long division if we wanted to, but this one can be done very well with synthetic division. Synthetic division is when our denominator is linear and has a coefficient of 1, leading coefficient of 1. So I'm going to come over here with a red marker, and I'm going to do my synthetic division down here in this little corner where my shadow is being cast on the board. And then we are going to take what we get when we divided it out and then evaluate it from there. And then I'll show you how to factor if you want to go about it that way. So let's start by just getting comfy, sitting down on the desk right here. We're going to be dividing numerator by x minus 3, which means in my synthetic division, I'm going to put a 3 here because it's the opposite of minus 3. And so from my 3, we will have 1x to the 4th. Make sure you can see that. Yeah, it's showing up. Sorry, I just zoomed right in. Oh my goodness, that was way too close. 1x to the 4th. I had to look and see if it was showing up on the screen. 1x to the 4th, 0x to the 3rd, 0x squared, 0x, and finally we get to our coefficient, our constant of 81, negative 81. Let's make that a little cleaner. There we go. All right. I'm going to go a little faster. You've seen this before. I would zoom in a little bit more for you, but that kind of freaked you out last time probably. Bring down the 1. Bring down your 1. There we go. Multiply by 3. You get a 3. 0 plus 3 is 3. 3 times 3 is 9. 0 plus 9 is 9. 3 times 9 is 27. 0 plus 27 is 27. 3 times 27 is positive 81. Negative 81 plus 81 gives me 0. We now have a remainder of 0, which means it does divide in evenly without a remainder. And so what we're going to do is use the blue marker, come over here and say, well, you know what? Here's what I'm really dealing with. Limit as x approaches 3 of 1x cubed, 3x squared, 9x, and 27. So 1x cubed, 3x squared, 9x, and 27. And now we can just plug a 3 in, and when we plug a 3 in, we're going to have 27 plus 27 plus 27 plus 27. That's 27 times 4. So I am going to just go ahead and write that. I mean, if you want to write it differently and show all the work, you can, but 3 goes here, 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 and we will have 27 times 4. So all 4 terms are 27. So 4 times 27, and that is going to give me 108. And so we have evaluated that. Just in case you're curious about how this numerator factors, I do want to show you. I'm going to erase some of the other stuff. So stick around on the video if you want to find out. If you don't, that's not going to hurt my feelings. But here goes. This is how we could, if we wanted to, leave stuff on the board and not erase it. This is how we could factor x to the 4th minus 81. Okay, this is actually the difference of 2 squares, and one of those is x squared, we'll just bring it over here, x squared plus 9, and the other one is x squared minus 9. Okay, and then we can actually continue to factor, and let's not talk about this one as much, because if we wanted to treat this like the difference of squares, we would have to dabble in imaginary numbers. Don't get me started on that. I love imaginary numbers. They do exist. They are misnamed. They are real things. Although they're not referred to as real numbers, but they exist. Nevertheless, we're not going to play that game, much fun as it would be. X squared plus 9. That could be x plus 3i and x minus 3i, but let's not. And then this does factor into x plus 3 and x minus 3. And so when I had this as a numerator, and I divided it by x minus 3, then I basically had this divided by x minus 3. And I'd cancel those out, and I would have x squared plus 9 times x plus 3. And if I was to multiply all that out, this is what I would get. And that's how it would factor. And now you know.